Afternoon session about the future future for video conferencing. Our first presenter will be Frank Rupen, who is working for Renater as a network engineer and in charge of video conferencing. He's leading the development of innovative solution and video conferencing services, and he's involved in the Rendezvous project that will be presented now. Frank, the floor is yours.
Thank you. Good afternoon. I'm going to present you a Renater service called Rendezvous. So what are we talking about? Rendezvous is a web conferencing service based on WebRTC technology and powered by Jitsi. WebRTC technology is the technology which allows your browser to perform VC, video conferencing, into itself, and by managing your media devices, such as a video media device and audio device. It also allows your browser to make a connection with another peer and send your media to it. With Rendezvous, you need to open a compatible browser, such as Chrome, Chromium, Opera, or Nightly. Into the application, you've got also some nice features, such as chat, Etherpad for editing some document with all participants. And also, you can share your desktop to make a presentation, for example. How it works? First step, you need to open your browser and reach the Rendezvous address into the address bar of your browser. Once you are connected to the portal, you just need to type a room name into the dedicated place, and then just go. If the room does not exist yet, the only thing you have to do is to authenticate, and then you join the room. What else? After this, you've got a valid URL, and you just only need to share this URL with your participants. Then enjoy it. So WebRTC carry advantages. And for example, the main important feature and advantage is the client-side solution is very simple. As I saw previously, you just need a web browser. And if you are able to open a browser and reach a URL, it's the only things you have to do. So it's very simple. And compared to other solutions, which could be more complex, this is one point very important for the success of the solution. It does not require any plugin. So you don't have to manage plugins. Maybe some of you experienced some some issues with plugin solutions, because when your browser is updated, your plugin does not work anymore, for example. It doesn't require also a complex network configuration. For end user, it's very important because sometimes it doesn't have any skill in network. And Skype showed the way of this kind of application. To make this simple for end user, you have to understand that behind the scene, you've got high technology engineering, because we have to assemble together a lot of standards. And this assemble of lot of standards make easy access for end user. So we hide complexity. Here, you can see our agenda we followed to make in production our service. We started in January 2014 by leading some tests with Jitsi team, and we saw that the Jitsi solution have a great potential, but in January 2014, it wasn't very mature solution. And Jitsi team worked a lot to make something more stable. And in May 2014, we were able to provide for our community a beta test platform and get their feedback. What we wanted was to collect feedbacks to know if the solution we proposed could meet with their needs. And of course, the users' feedbacks were very, very positive. So in October 2014, we started with Giant pilot platform. And between October 2014 and March 2015, we developed some missing features which were required for enter the service in production. So in March 2015, Service Rendezvous was in production. What is Jitsi Video Bridge? It's an open source project first. So everyone can download the software and run it. It's also a multi-layer application because there are multiple components which are refilled with an area, and I am describing this multi-layer application in the following slides. There are XMPP, WebRTC, and media components. There are also nice features, such as the ability for an operator to run this solution as a virtual machines. And this is very important if you want to build a scalable system to provide a large massive conferencing system. There are also nice features such as simulcast and last 10, which allows to improve the streaming of the media to participants. ICE-TCP also to get the ability to cross firewalls and NAT traversal. So let's dive into the core of the service. On the top of the stack, you've got an access layer with your browsers. Browsers are the only requirement to access the service. These browsers reach the Jitsi Meet server and download an application, a JavaScript application, which is a WebRTC application. Once it is this application is executed, the application can take control with your devices and make the connection with our system. It is very important to understand that the signaling system is performed by our service. Here it's the GCOFO server. And the GCOFO server relays the browser and the video bridge signaling, and it makes possible to send after the RTP streams between the video bridge and your browsers. So there is a signaling port and a media port in our service. There are additional features because, for example, we need also to be compatible and interoperable with legacy systems. And Jitsi solution come with a SIP audio gateway. So we are able to make an outgoing call from the Jitsi video bridge to a SIP audio phone, for example. It will be also possible to make an ingoing call when we will be able to develop components which are missing now. Jitsi provides also a recording solution. It's possible to instantiate two components which record your conference. In Renater, it is not deployed yet because behind these two components, we have to deploy a workflow because this feature could involve some cost for storage, for example. So now it is not yet ready in Renater. This solution scale, but why? Not only the virtualization is not the only reason, because there is also a model behind the way to stream your media between all participants. The first model is the full mesh. When you think in terms of WebRTC, remember that WebRTC makes peer connection. So full mesh is a more simple way to relies on multiple points, but it doesn't scale. The star model is a well-known model in VC solution because this is the MCU model. The central node centralizes all the streams, it transcodes all the streams, and then it sends to the participants one stream. This model may scale, but if you virtualize such solution, you can involve also some latency, and it could be a problem. And also, you can surely, in virtualization, just send a few streams, not very much. And the last model we've got, it's the full star model. This is this one, Jitsi embed. This is the SFU model, Selective Forward Unit. Jitsi is not the only solution based on this model, because video also run on it. In this model, you send one stream, and you receive all the streams of the participants. So central nodes has to guarantee improvement in the way to send you all the streams, because after your browser could be overloaded. Now, for an operator, what was missing when we started the project? When we think in terms of production mode, we need some monitoring system, authentication system, high availability, load balancing, and scalability. These things were missing when we started the project. So now we are able to authenticate, and with this authentication, we can only figure out that the only users who are allowed to create a room has to be authenticated. After, if you want to invite all other participants, you can, and they don't require any authentication. So today, Rendezvous service is available through same LV2 for accessing. Jitsi Video Bridge is now, we are able now to run the service with multiple bridges. So in Renater, we've got 2 bridges. And with these bridges, we've got high availability for the service. And also, we are able to load balance the conferences between the 2 bridges and get some redundancy. These 2 charts show you that the two bridges we are running get almost the same workload during here it's 1 month. Over 1 month, you've got almost the same shapes on the two charts. So load balancing works very well. To operate this service, each bridge is only 8 vCPU configuration with 8 GB memory and 1 GB network interface. Of course, it is possible to get only 4 vCPUs. It works also. And with this configuration, for the 2 first months, we were able to operate 5,000 conferences for a total time of 145 days. And the average time of a conference was 42 minutes. Here, you've got the workload of CPU. So we've got some margin. And here, it's only the bandwidth we were used on one bridge. And here, the peak is 9 megabytes. So, with this project, we showed that we are able to provide access to extend the access for our service, video conferencing service, to a population which was excluded before, such as students. Rendezvous has also proved it's a tremendous success for our users. This is their feedback. And we are also able to scale with cost optimization because we are able to run this service only in virtualization mode. And maybe the most exciting thing is the ability for us to provide also an API to developers who want to implement our solution into their own developments. And we will lead these things in Giant SA7 and SA8 for the future. Thank you.
Thank you. Any question from the audience? Can you pass the mic on, please? It's over there. Okay. So, Joao, is your...
One, yeah. Hi, Frank. Thank you very much. It's Joao from CERN. I have 3 questions, actually. So my first one is, when you say that the service can scale, where do you think the boundaries are? How many simultaneous users can you have on Jitsi? Or how many simultaneous users you think you can have with the current architecture? So this is the first question. The second one, I would like to know what made you go for Jitsi instead of another open source solution. What were your key requirements that you found in Jitsi, not in other open source solutions, because there are many open source WebRTC solutions. And the third one is about congestion control. I know that some of the open source solutions did have problems on these algorithms because they didn't have anything implemented to make congestion control. I'd just like to know if Jitsi has this or not yet. Thanks.
So first question. Jitsi let some test with their Hammer solution to overload this solution, and they published all technical results. In my memories, for 1 gigabyte, you can stream almost 80,000 streams. But we have to take care because it depends also of the topology of a conference. If you have one conference with 80,000 streams. It's not the same thing with multiple conferences between with multiple streams into it. This is the first thing. Second, it was
why Jitsi?
Sorry.
Why Jitsi, not another one?
Sorry.
Why Jitsi, not another one,
Yes.
another open source solution?
Okay. It was an opportunity. I met Emily Voff during a session in France. We share the same conference session. And we talked about its solution. And then he proposed to me to try it. It was a start. And things are going on this way. But after, I know there are other solutions. This solution seems to scale. We try it. We help this solution by make some requirements and so on. And it seems to be very good. And third?
And the third one about the congestion control. Do you have any test?
There are, in the GT video bridge, you've got some statistics. So you are able to tell if you've got some packet loss, if you've got, what is the rate of download and upload flows. So this is the things which are embedded into the video bridge, and you can monitor them. In real time, I do it with a real-time solution based on REST API. I write some code easily to reach the REST API, and then you put this metrics into real-time DB, such as InfluxDB, and you can plug your Grafana dashboard, and you see all what you want. It's very easy and nice. It works very fine.
Okay. Unfortunately, we are quite tight on time, so thank you very much for the presentation again.
Thank you.
Our next presenter will be Michael Stanton and Tatsuya Fuji. Michael Stanton is Director of Research and Development at RMP, the Brazilian NRN. At RMP, he is responsible for R&D and RMP involvement in new networking, large-scale collaboration projects. Tatsuya Fuji received his BS, Master and PhD degree at Electrical Engineering from University of Tokyo. He is currently studying real-time 4K video communication system architecture as well as reliable content distribution system at NTT Network Innovation Laboratories. So, Michael, please start.
Thank you. Okay, good afternoon, everybody. This is something a bit different from the previous talk. We're going to talk about live television broadcasting from Brazil to Japan. And there's a context behind this. There are two speakers, as was mentioned already, myself and Tatsuya Fuji from Japan NTT Labs. And we're going to present different parts of a collection of ideas about what we actually did last year. This is the abstract of the talk, which I think is on the website. The principal thing is that the technology, the video technology being used here is 8K video, and it's complemented by surround sound, 22.2 channel audio, and this combination has been selected by the Japanese television company, NHK, as the next generation of television, and I'm going to talk more about that. So we're going to describe something about SHV technology, how the network infrastructure was created to transmit this content halfway around the world, and my colleague will talk more about some of the error control mechanisms which are used for managing this. And the net result was that we were able to transmit 9 live games from the 2014 FIFA World Cup, which was held in Brazil. These are the main partners, NHK Television, NTT, which is a telecommunications company, both from Japan. From Brazil, we have 3 institutions, TV Globo, which is our largest television network company, based in Rio de Janeiro, RNP, which is the NREN from Brazil, it's also based in Rio de Janeiro, and CBPF is the Brazilian Center for Particle for Physics Research, which housed a little theater for letting us watch the games which the television people were producing. We also count on the collaboration of a number of other organizations who helped us with the transport of the signals from Brazil to Japan, and they're all listed here. The major contributions is demonstrating this technology for large sporting events. It's not the first time, I'll mention this afterwards. There was effective compression techniques, about 100 to 1 for 8K media, which reduces the required bandwidth to about 350 megabits per second, which is quite effective. It means you don't have to have very large networks in order to use this. And the idea of transmitting in lossy media over shared IP networks over intercontinental distances. So I'm going to talk firstly about this. This is some slides I was loaned by our friends at NHK, and it talks about what is SHV, what is 8K. These are some of the slides which were made. As I said before, NHK wishes to regard this as what will be the ultimate generation in 2D television. And there's some detail about this here. The main thing is the immersion quality of the experience of watching and hearing what's being transmitted. The screen size is large. This 22.2 multi-channel 3D sound is extremely interesting if you're sitting in the middle of these loudspeakers. It's something I recommend. I can't describe it very well. So far as the image resolution is concerned, this is a comparison of HD, high definition, or 2K resolution. 8K corresponds to an image size which linearly is 4 times the HD dimensions in terms of pixels, so it has approximate, HD television has approximately 2 megapixels. This has about 33 megapixels, so it's a lot higher resolution. The other thing is, as I mentioned, it's immersive, so instead of watching it in the other side of the room, you actually get very close to the screen, and you have to look at different parts of the screen in order to follow what's going on. It's quite an interesting idea. These are some of the perceived other applications apart from television for this. We're already doing many of these things with 4K resolution or even HD, but there's another extension to this idea in this other area. For NHK, this process of producing this product, if you like, this approach is 20 years old. They began their project in 1995. And there are some points on this. The first public demonstration of this on a large scale was in the London Olympic Games of 3 years ago. And my friend here, Tim Boundy from Janet, was involved on that occasion. In 2014 is the World Cup. They've now gone off research. They're now putting this into production. They intend to start broadcasting by satellite in 2016, the next Olympic Games, and by 2018, 2020, this is expected to be widely available in Japan. Some of the equipment that has been developed by people, on the top left is the first 8K television camera, which was produced, 2002, and at the bottom, this weighed 80 kilos. The current range of cameras includes a portable weighing 2 kilos, so there's been a great improvement there, and a larger machine for more regular use for televised, probably. Here on the right is one of the important things, the codec for 8K, which produces this 100 to 1 compression that I mentioned before. Some of the output displays are shown here. projectors, two kinds of projector, two kinds of display panel. And this is a summary of what happened in Brazil last year. And the bottom left shows the generation of the images at different points in Brazil where they were playing football. This all brought, I don't know if I have a pointer, yes. So I can't see the point, unfortunately. Yeah, it's difficult. Anyway, I'll come back to another idea, another presentation of this shortly. But essentially, the idea was that these images were transmitted to Rio de Janeiro, displayed there, and then shipped from there across the oceans to Japan. So let's progress with that. Okay. So RMP's involvement, we actually attended a presentation by Tim in 2012 at the autumn members the spring members meeting in Washington of Internet 2, and that's where we learned what it was going to be used for that year. And as Brazil was hosting not only the Olympic Games next year, but also the FIFA World Cup finals last year, then this it seemed to us that what Janet could do in 2012, we could perhaps also do something similar 2 years later, 4 years later eventually. So there are problems, bigger problems for transmitting from Brazil to Japan. As you see, the two cities involved, Rio and Tokyo, are almost antipodal, on the opposite sides of the globe, which means that the distances are about as big as you could get on this globe. The Great Circle route is 18,500 kilometers. The network route is over 23,000 kilometers. So the end-to-end delays are rather large, as you can imagine. So this is our collaboration milestones. I think I'll skip those. But essentially, we made contact with the people from NTT first, at a meeting in Philadelphia in autumn of 2012, and since the beginning of 2013 they've been collaborating with us. They came first to see if we were serious, and then after that spent more time with us, and we eventually came to setting up this project and doing everything last year. So, logistics. The audio-visual thing was capture was provided by NHK. There's a media center set up in Rio to distribute SHV media to different places locally and overseas. The NTT managed media transport, and this is what Tatsuya is going to talk about, and also developed the error control for this. And we provided the infrastructure within Brazil for all the different things that are needed to make the bits stick together. This is the last slide I have. It just shows the media flux from the stadia here, different ones that were in 3 different cities around Brazil. There's a local national network operator, Telebras, which brought the images to Rio, to the FIFA Media Center, then passed on to the RNP Media Center for SHV, and then transmitted locally to display stations within Rio, public viewing stations, or across the networks to Japan. So I'll pass on now to my colleague, who can tell you more about what's going on.
Thank you very much. Also, I'd like to continue the explanation how to transmit 8K super high vision stably using multi-domain end-to-end networks. In order to conduct 8K public viewing in Japan, compressed video streaming of 300 Mbps should be transmitted continuously, spanning 23,000 kilometers from Rio de Janeiro to Tokyo, even though there are so many users sharing the network bandwidth. The goal of the project was to establish a completely lossless IP packet transmission between Rio and Tokyo for 8K video transmission. So we needed to consider how to secure the continuous transmission in each games, in total 9 games. Also, we needed to keep the good condition of networks for as much as 1 month. To do that, we took 2 approaches. The one was forward data collection, NTT developed. The other one was multipath transmission. And this is an overview of transmission for 8K public viewing. The camera part in the left and the playback part in the right were prepared by NHK and TV Globo in Brazil. My presentation is focusing on the hatched part, receiving transport stream from NHK's camera system, then sending them to Japan to deliver the stream to the public viewing sites in Japan. One important technology for this transmission is FEC, Forward Error Correction Code, to rescue IP packet from the drops in the shared networks. Using FEC at the transmission side, IP packet data are temporarily buffered, then calculate a parity using data from them. Next, both buffered and parity data are transmitted to the networks. In the network, some IP packets are lost due to the congestion or malfunction of the networks. But these lost packets are reproduced by FEC calculation from the received packets. There are so many fake algorithms studied all around the world, past and now. They have different characteristics on calculation cost or how efficiently the lost packet can be reproduced. Firephoto LTGM FEC is NTT's original algorithm, featured by low computation power required to encode and decode, and high probability of successful reproduction. And this algorithm was just adopted as an option of FEC part of MMT, MPEG multimedia transport, new transport stream format, standardized in this year. We implemented Firephoto LGGM FEC into simple PC system, which works like a proxy server. Oh, sorry. So we can easily insert these boxes into the 8K codec system developed by NHK. So Firephoto FEC is so lightweight, we could set the FEC block size to as much as 150,000 packets. So with 20% redundancy by FEC, an extra long burst of packet loss of 20,000 packets can be salvaged using this system. So total throughput of this system was around 700 megabps. This limitation was due to the performance of small bookshelf type PC system, including AES encryption required by NHK to protect 8K content from the shared network. In 2012, NHK, BBC Janet, and NTT conducted another experiment from London to Tokyo, asking the support of Jian and Internet Zen signed for. And Tim is a major member of this project, as Michael said. At that time, we prepared 2 links from London to Tokyo. But unfortunately, the main pass got trouble just 1 hour before the live streaming of the opening ceremony. So we eventually we could do successful demonstration using the subsystem changed by hand. But we are convinced we need more improvement. So this time for the World Cup, we carefully designed the network so that we could maintain the total system during the FIFA games for 1 month. So mainly of endurance Internet 2, Red Clara, and SciNet4 helped us to construct 5 network links from Rio to Tokyo. So parallel transmission was additionally used this time to enhance the stability of the transmission. To conduct 8K public viewing for 1 month, we could imagine there was so many unscheduled maintenance of the network and the system trouble or power outage of the network nodes. So we transmitted 2 streams of the same 8K video audio with fake redundant data using quite different links each other. Either one of them reached to the receiver side packet by packet, the video codec could work properly. So this slide shows a detailed network diagram of 5 links we constructed. So red lines are primary link pair used for the live public viewing for games. They used entirely the different links and nodes. Blue lines are secondary link pair for backup. They use a common node partially. So we installed the system of transmission side a half year before to start the testing network. The left picture is lack of the POP of RNP located in the CBPF building. Then we installed the receiver side system as shown in the right picture into NHK's Central Broadcasting Center. So these 2 pictures are venue of 8K public viewing using commercial movie theaters. In total, hundreds of visitors visited to view, even though the live viewing started early in the morning, usually 2 a.m. or 4 a.m. So time difference is a very severe problem. During the game days, we continued to measure the network condition by inserting the test traffic. And these table shows result of transmission. In the primary link pair, each link showed 20 times or more incidents of large burst packet losses. But combining 2 links, there was no error entirely in 35 days of the game weeks. So even though we combined 2 links, some packets dropped simultaneously in both links, but they are all salvaged by FEC. So lesson learned. So based on the experiment in 2012 in London, we enhanced the reliability of 8K video transmission. So we could show the flawless live public viewing of in total 9 games during the 1 month, not only 1 game, and not only 1 day. But the total bandwidth required to 5 links was too much. This is a current problem to be solved. So in conclusion, we made a 8K public viewing successfully thanks to all NLANs who supported us. And the next study to enhance the reliability while reducing the redundancy. Maybe we will never transmit the same transport stream to 5 links simultaneously. So especially to transmit uncompressed 4K or more, at least 6 gigabps is required to transmit. So we are now planning a new project using an open flow switch and dynamic network monitoring to control the network path. Okay, many project members and supports from NLANs. Thank you very much.
Any question from the audience? Yeah, over there at the last, almost the last row. There, behind you.
Could you please say how much delay you introduce when you use the forward error correction algorithm?
So the delay of the forward error correction.
Error correction algorithm.
The total delay is around 5 seconds because we set the block size as much as possible. So 150,000 packets correspond to the 5 seconds. Oh, sorry, I'd like to correct. In total, 10 seconds delay in FEC systems. The network delay is about 150 milliseconds. It was negligible. So the delay time is very severe problem. But in this case, we don't need any returning path, so it's not mutual communication. So we could set the delay time as much as possible.
Okay, thank you very much.
Thank you. Thank you very much for your presentation. It was very useful.
Thank you.
Our next presenter will be Tim Boundy, who was involved in the London experiment with this very similar setup. Tim is JISC application development team manager within the strategic technologies division of JISC Technologies. Teams have a current focus on video conferencing, ultra high definition streaming, LoRa and other video application. Tim, please.
Thank you. Hi, everybody. Thank you for all the name checks, Michael. I wasn't expecting that. I hope you had as much fun as I did at the Olympics. It was super high vision. It's cool, by the way, in case any of you ever get the chance to see it. It's really good. I was expecting a larger picture than that, but we'll see if I can. Okay. Okay. So we. Well, whilst that's sorting itself out, you've already heard from Frank about WebRTC and Rendezvous, which probably is the future of video conferencing one day. So sorry, we're not on SHV anymore. This is back to the everyday world of video conferencing. I'd recommend you have a look at Rendezvous. It's very impressive. After me, you're going to hear from Bartek, wherever he is, to talk about EduConf, which is the current world of video conferencing in the often harshly used term legacy video conferencing. I can't say I agree with the term, but people seem to know what it means nowadays. So what I'm trying to provide is the reality of video conferencing today, which is essentially the bridge between the two. The current world, and I'm willing to bet that all of your NRENs have current video conferencing architecture, or at least users of video conferencing systems who don't want to immediately get rid of their current ones. Oh, thank you. But you're also interested in looking to the future, and you want to keep track and make sure you're equipped to ride the wave of future technologies. So what we're trying to provide at vScene is a bridge between the two. When WebRTC becomes available as an everyday technology, we will undoubtedly absorb that as well. So please don't view us as a stuck in the legacy world, because we're moving with the times. So right now, vScene is the JISC video conference service that the point of this presentation is to describe it and also offer it as an NREN service. And we're very excited to say that Géant have been in talks with us and are extremely interested in looking into this as well. So I'm going to try and answer 3 questions during this. Why is this so difficult? Video conferencing is still a bit harder than it really should be. Why is it worth it? We're still trying, even though it's still a bit difficult. And then how can we help? But we have to go back in time a little bit to look at when JISC started. So back in 1995, I know they had color cameras then, but it makes it look older. We started a video conference service. This is also what was going on at the time. I just typed in 1995 and got these pictures. Anyway, so the JISC video conferencing service has been running for 20 years. On the 30th of July 2014, we launched a redesign of it. We reintroduced the video conferencing service as vScene. And at the time, you can see we had 8,000 video systems and about almost 10,000 users, and we transferred them all over. The reason for this change, reason that change was required, because we needed to move with the times and address our new customer requirements. They wanted us to adopt new models of collaboration. There are lots of different ways of launching a conference, so we need to address expectations. We also needed to avoid a single point of failure we had with the old developers, and significantly reduce the costs of running the old video conference system. So that needed a complete service review. So again, why is it a challenge? Why is it worth it, and how can we help? Well, the challenge is often in video conferencing is to do with the concepts. There's a lot of confusion out there of how to launch a video conference. I'm sure you've all heard these questions. You'll have witnessed people asking things like, can I use the nice video conference system to call someone on Skype? And we still get that question. It's going to be there for a long time. And at the moment, unfortunately, you often get the answer, no. What, of course, we want to be able to tell people, so therefore, one of the main objectives of vScene is yes, and here's how. So, of course, that gives us the direction of work. We are working towards interoperability in every direction we can. Of course, we will never achieve this. It's an ever-moving target, but this is a direction of development. And it doesn't matter if you can't see any of the texts, you can just see the mixture of crosses and ticks on this, comparing all these different video systems. There's a lot out there, and they all do different things, which does make it difficult when you're looking at different concepts. So another common question is, what happens when I click Start? Depends on what you're using. So often the answer is going to be, or the question is, does this mean I need to join, call, connect, dial, book, schedule, launch, or just wait for something to happen? And every different system is different. So again, the answer to this from your tech support is going to often be, it depends on what you're using, or here's how to use the one video conferencing service that we've invested in. So we've got some problems there too. Lastly, you of course get the CEO coming along and essentially saying, just make it work. And this again, I'm sure if any of you are trying to deliver services under the descriptions of your CEO of make video conferencing work for me, what you're actually thinking in your head is this, but really what you should be saying is this, I'll do my best. So that's what we're trying to do, as I'm sure you all are. So these different concepts, we need to start addressing the different ideas of conferencing, and we need to try and design a service that addresses as many as possible so we don't leave anyone out. So you've got the two major ideas of, is video conferencing person-to-person, or is it video system calling a video system? Now, the world is moving much more towards personal experiences and personally identifying yourself in a collaboration environment, so really, we need to be looking at person-to-person. The old service was very much book that piece of hardware with this piece of hardware. So it's two different ideas there. Are you arranging a meeting between two shared physical rooms, so the actual room in the building, or two endpoints? Another different way of looking at it is the thing that you're calling, does it have the name and description of the room in the building, or does it have the name and description of the actual piece of hardware or the codec? When do you do this? Do you just immediately launch it? Are you comfortable with that? Do you not worry that something's going to happen? Do you need any support? So can you just go, I want a video conference now? Or do you want more support, and can you plan your days out, your months or years out in advance, which we find is a very common use case in the UK and in academia. In education, people know what the timetable is going to be, and if you can spend half an hour at the beginning of the year scheduling all of your conferences in, then this makes the rest of the year much easier and smoother for the lecturers and anyone who's involved because they don't need to do anything at the time. So booking or scheduling things in advance is often really handy. Even if you don't really need it for resource limitations, it's good for the users. And then you've got the two different concepts of where are you actually meeting? Where does a video conference happen? Are you in a kind of semi-permanent virtual room, like when you have a telephone conference with one person? Where is that telephone conference happening? It's kind of in a semi-permanent link that just exists for that moment. Or, alternatively, when you have a teleconference, or when you have a video conference in what you've decided is a room, are you brought together in a long-term existing room? So either temporarily brought together, or is it semi-permanent to exist? I think I confused those two up a bit, but you get the idea there. Does this entity exist long-term, or is it just brought to you for that one conversation? So, again, why is it worth it now? Well, you probably already know this. And I should probably thank Rob Bristow, who's somewhere in the room, for being a major part of the research that gave us these figures. In 2012, the UK education sector saved due to these calculations, £66 million and 10.25 tons of CO2, which is impressive and easily justifies video conferencing just by itself with those figures. But the other arguments that are often unsaid, but in reality, why do you want to do a video conference? Because standing in train stations is boring. And if you can avoid traveling as much as possible, you will do that, especially when you're probably people like us. We go to a lot of international conferences. You can see that this does wear on you. Also, driving a long way is very tiring. Again, you're going to want to avoid that. So lots of good reasons why you should do this. Now, lastly, we've discussed why it's difficult and why it's worth it. How can we help? Well, vScene is the service that I'm here to describe. It's JISC's attempt to try and merge together a new approach towards video conferencing, but also try and be a bit more open and provide a consistency for video conferencing users so that they don't necessarily have to move when a new technology comes along. We worry about that, and they just keep visiting the same place they always visited when they wanted to have a video conference. So the new approach, although some of these are not really new ideas, they're just us updating and delivering users' expectations. We're now looking at this as people and conversations, not bits of hardware. So you will find yourself typing in people's names. It's going to have an intuitive enough interface so that anybody can arrange a video conference. You don't need to call anyone up or schedule it, or have anyone else arrange it for you. We're looking towards interoperation. We're trying to avoid people getting stuck in closed communities of conference solutions that means they're stuck there and they can only talk to those people that have got that. Because you know how annoying it is to have to repeatedly download yet another video conference solution. We're providing an updated desktop client, and of course we will continue to move with the times on that one. And we're focusing now on immediate conferences, although people still want to be able to book it, adding all new features all the time, and importantly, we're trying to provide a platform that can be used as an NREN service. Okay, so let me try and move to the demonstration now. There we go. I'll move that up a bit. Okay, so this is the front page of vScene. I'll give you some information about the structure in a moment. I'll log in here. You can see we've got federated login options as well. One of the other NRENs that's using this at the moment, HEANet, I think Kevin's in the room somewhere. He promised me he'd give a wave and a thumbs up. I can't see him. Anyway, the HEANet users of vScene have a different interface on the front, so they can change the color, change the login systems. So this is the JISC interface. Let me just reposition that so you can see it in the middle there. So this is the front page here. You can see we've immediately provided upcoming conferences. So I'm an administrator, so I get to see quite a lot of conferences here. A normal person's probably isn't that much. You can see... Stop doing that. You've also got your list of meeting rooms. So we've gone for two different concepts. We're providing two concepts of having a video conference here. One is to arrange a conference and just launch something. And the other is to have your own virtual meeting room. So I'll show you both ideas here. So this is your virtual meeting rooms that you've recently visited. Top 5 contacts, top 5 video systems. So the quickest way to just connect somebody is 2 clicks. You've logged in. There's Emma. I video conference with Emma a lot. I don't really. She sits on the desk behind me, but she's listed here because I use her in all the examples. So I can just click this camera here, and it starts to book a conference, a scheduled conference, and you can see it populates the booking page with my name and my favorite video conference system that I've already registered, Emma's name and her favorite video conferencing system. As a user, I have no idea what Emma's video conferencing system is, and I don't need to know. It could be an ISDN system, it could be a SIP address system, it could be a piece of software on a laptop. In that case, I happen to know that the development system there is a hardware codec in the development room, and the other one's one on my desk, but it doesn't matter. I've just clicked Emma's name, and I can scroll to the bottom and click Start. This will send commands via API to the MCUs, and it will launch the conference between these 2 sites, and the conference starts. So you can see 2 clicks, and you've launched a conference. But if I didn't want to conference with Emma, I could just add other people's names. So let's start typing in some more names. There's Mark. Put him there. And it adds his video conferencing system here. we can add a guest. So if I go guest, not found at the video system. So now this guest here can be allocated a guest video system or put in one of the ones that exist that I've got access rights to. So a guest system, though, how will my guests connect? We'll provide them with the free VC and desktop client. And of course, you can also provide guests on telephone or SIP, dial-in IP, however you like. So I'm building a conference there, and I can either just launch this now or schedule it for later and also have it repeating. Other options, I can opt for this to record, to stream. I can give different people management rights over this conference. And all these features are available to all of the VCN users. So this is a centrally provided service with all these features to anyone on JISC. So that's how we schedule a conference. I won't click launch there, but I'll go to the meeting rooms. So you can see this is a list of some of the meeting rooms we commonly visit. Tim's open meeting room here. Now, each of these meeting rooms, anybody can start a meeting room. Any user can have their own meeting room, which means that you get a static IP address, essentially, or a static address for your room. So you can see this one here has got a GDS address, an IP address, and we're going to add a SIP address soon, and a standard name. So this addresses one of the requirements of our executives who just said, I just want the same number for people to call me on every time, no matter where I am. So by creating a central thing, they can all join in the same place in this room. And this is scalable because we're using video hardware to deliver these meeting rooms. So you can see I can just launch into this meeting room here immediately, but I'm going to show an example here where there's a Tamberg system behind us. Is the camera on from that? It's rather dark. Maybe it's just pointing at something dark. So you can see to join this meeting room here, I'm going to, and in fact, if I open another tab for this, so we've got another, as if it was another person. So this, enter Tim's meeting room by clicking on the camera. Let's use the video conferencing system in the corner there, which I've already registered and called Alfandega. There it is, that one. And I click join there. And then vScene dials out to the video conferencing system and connects it to the meeting room. I can also then click, let's go find that meeting room again. So there it is on the second page. Join the meeting room using the desktop client and launch it from my browser. And you will see my ugly face on 2 screens at once, 3 screens at once, in fact. Wow, that's far too much of me, isn't it? Okay. So any users can start the room, and of course you can see that they can join this room. Sorry, that's really awful, isn't it? They can join this room from software clients on their browser, hardware systems. They can add telephone guests. So it becomes a flexible environment they can use ad hoc whenever they feel like. The rooms can be open so that anyone can find it, or closed so they can just hand out the address to whom they see fit. Okay, so I will hang up on this desktop client because, crikey. Okay, so that's the major features of VC in there. If you record a conference, you can download it a few minutes later. We've got about the same number of users you saw before, almost 10,000 users, 9,000 video systems, and more are joining every day. The meeting room functionality in particular is adding another type of guest, or another type of user group who didn't want to schedule before, but enjoy the fact that they've got a flexible location to meet, and that's proving very popular. So all of these features are available for other NRENs to use. So I'll describe to you now how vScene is actually structured. So I'm going to go back to the PowerPoint. Okay. So looking from the perspective of coming in over Janet, we have a VCS infrastructure dealing with our addressing and routing. And then connected to this, we have Cisco MCUs and Cisco ISDN gateways. And we use these to connect the legacy, if I have to use the term, H323 and SIP endpoints. ISDN endpoints, we still have a lot of those in use. And telephone clients as well, connecting via this way. We've also got a system of VisiMeet servers, which is a collaboration tool, which is quite cool. We use some people use on laptops and mobile devices as well, so they can be connected into the conference too. And then we have a video estate as well, also connected in. So we've got a video portal with a pool of routers and gateways and a cluster of replays. So we can use the routers to provide video web, which you just saw there as the desktop client. And that still includes content sharing, and you can use it full screen in HD. It's really quite a flexible little tool. And you can see the gateways we can use to connect H323 and SIP clients as well to that environment. So we can got two options there for bringing in standard systems. And of course, we use the clusters, the replay cluster, to record and stream. As I mentioned before, vScene isn't just a service for JISC. We're also offering this service to other NRENs. HEANet is one of our current users. And you can see that this means that they've got their own Cisco MCUs. Now, because of the way that vScene works, their conferences use the Cisco MCUs that they've provided there, but also our MCUs and the video estate if they don't have enough resource. So they still get all of the features of vScene, but they've provided some of their own resource, but they can use ours as well. There's, of course, potentially to add other NRENs very easily. And either they can come on board with the Cisco hardware, or maybe they might have another video estate, or maybe they might have nothing and we'll offer the entire service to an NREN that wants to have a fully fledged video conferencing service. All of the hardware that's involved in this, of course, is managed by vScene. So this is one point you'd come to, and you don't have to worry about how your conference is delivered. So what does vScene actually do? Well, a user will land on vScene via the branded interface that their NREN has set up, and then be directed into the vScene functionality. So the two main use cases or immediate operations are they either choose that they want to enter a meeting room or they want to start scheduling a conference. So they enter into one of these options here. And they then decide what they exactly want to do and form that into their kind of request, their action for vScene to deliver. vScene then looks into the database and works out, okay, who are these people I'm supposed to be connecting? Do we have video systems for them? What type of system is that? Has it been tested recently? And it then applies the resource usage rules, so we know that the correct resources and infrastructure is being used for that particular user. It then looks at how busy is this particular resource, so we can load share across the systems and make sure that the video estate or the MCUs are not being overused in any one particular way and deliver the appropriate response to the user. It then chooses one of the resources to use for the conference, works out the API commands to deliver, and delivers that and creates the conference. So we're offering vScene under a number of different tariffs within the UK at least. We've got education and research, and this at the moment is centrally funded, so it's free to JISC users. We are developing a public service tariff, which is a reduced rate for public sector bodies, and we have a commercial tariff as well. So this service is open to a lot of different people, and we're working with GÉANT and the GÉANT model on an international education research tariff as well for NRENs. So they get a number of features. If you're a different NREN, you can bolt on the options available of using your existing infrastructure. You can migrate all of your users across in one go. We can use different languages on the interface if you want to translate it. And of course, you can add your own branding and make it appear as you wish. And that would create what we're calling a super organization, an NREN. Service support. You don't need to see all this. It's at a good level of service support, 99% availability. We have a team of operators in Scotland who are very friendly and very happy to answer all your questions, and I know that the users appreciate them. And that's me. So thank you very much. If you're interested in learning more about vScene, then come and talk to me or any one of the other JISC people. We are in discussion with a number of different NRENs at the moment, and we're happy to talk to more. You can try it out at any time you like. And I think Janis is going to step on the stage, but just before he does, I've got 5 pictures. These are different views of people doing video conferencing. We've all got a different view of video conferencing, and you are all guilty of this. I do not want to see you video conferencing from anywhere. I know they say you can. It doesn't mean you should. So noisy offices, bad idea, don't do that. Also, sit in front of the camera. You'd be amazed at the number of conferences I see where people are doing this, even with really experienced people. Don't do this, it's horrible. You can see these webcams and laptops. And again, please consider your pictures. So these are different views of video conferencing from people who clearly have no idea what they're doing. So, thank you very much for your time. Have I got any time for questions?
Yeah, one question maybe.
Okay.
So,
yeah,
question from João, please.
Thank you. One? Yeah. Hi.
Hi.
Nice presentation. I just have two questions very fast, okay? So the first one is, what is your proven number of concurrent connections right now in vScene? These I would like to know. Yeah, how many people did you have up to now connected in vScene in a production model or in a production environment?
Do you mean concurrently connected?
Concurrently connected.
How many can we or how many have we?
How many did you have as a peak up to now?
The busiest?
Yeah.
We have reached capacity. So this is 200 HD on the MCU. This is 200 gateway ports on the... I mean, this was a very special event, but so nothing that normally happens. But normally running, we're about between 60 to 80% of capacity on a typical busy day, which is about 2,000 conferences a week-ish.
Changing the
Okay.
I don't know if that answers your question. It's a very complicated question, but really.
Yeah, I know. I just wanted to know the peak number of concurrent people connected to the system. So it's 200, 500, 1,000, 100, just this.
At the moment, it depends how they join, as you well know.
Okay. So the second question is, do you support federated SSO right now on vScene, or is something that will come? Federated SSO, SAML, federated SAML. Okay.
Yes, we support the UK Federation and EduGate for the HEAnet, and we're happy to add any other federations and possibly EduGate in the very near future.
Okay, thanks. That's it.
Okay?
Okay, thank you, Raj.
Thanks.
Our next speaker will be Bartolomiej Idzikowski. He's graduated from Poznan University of Technology. His research interests focus on video conferencing, high-resolution video systems, 4K, 8K, web-based application streaming technologies, and network management and traffic monitoring. He participated in several European projects from 6net to Géant and Visionaire. Bart, at the moment, he will speak about the EduConf services of Géant project. Bart, please.
Good afternoon, ladies and gentlemen. My name is Bartek Idzikowski. I am from Poznań Supercomputing and Networking Center. And I am also involved in Géant projects, so I will present the technical background of our product, EduConf, where Tim, again, is task leader of that task. What is EduConf? In few words, we created EduConf to assist research and edu societies to help them with their video conferencing aspects, especially by affording services as testing. So users are able to test their own device and check whether they are configured properly and whether they are working correctly. The second service is directory. Directory services is providing possibility to store details of your video conferencing system into the directory system just to allow other people to search those video conferencing services and terminals especially, and allows you also to search the video conferencing equipment within the Europe. And the third important thing is we are providing monitoring service both for testing your endpoints, but also to test your whole infrastructure, your whole video conferencing infrastructure basing on your gatekeepers. I will tell you this in more details soon. What were the general assumptions for the architecture? It was supposed to be as easy and transparent and seamless for end user as possible. So we tried to make it the whole test procedure and monitoring procedure as easy for user as possible. And we took all the complexity of that process to the backend just to make users' life easier. The system is built with two independent components, so the testing directory service as the first one, and the monitoring service, which are interconnecting between each other using JSON-based communication, which was designed. The communication was designed by our team from scratch, and this communication is responsible for full control of all stages of the process. Of course, both from making and confirming the request. And of course, we are using federated edugain login system because this is very useful Jean service, and we decided to use this as well. Here you can see the overall architecture of the system. So the most important part of it is user with his or her browser and video terminal. The web browser is required to have an access to the directory, which is also interconnected with edugain, as you can see, of course. And the second thing is monitoring, which is responsible in this case for creating virtual terminals using CallGen from Opal library. And we are also registering those terminals into gatekeepers. Our infrastructure consists also of two word gatekeepers. One is using for every day, and the second is a backup one. So this is the overall infrastructure and interconnections between those nodes. And what is user expected to do in order to test his video conferencing terminal and add it to the directory? There's just three simple steps. First one is call provided test number, which user can see on the web browser. In the second step, user is asked to answer the incoming call using the video conferencing terminal. And the last thing is to update and confirm information that was automatically gathered on the web page just by clicking I confirm. And now we will show you a short demo. Of course, we can log into the system, as I said, using edugain. So this map shows the directory details of our, in this case, this is our room in Poznań. There are plenty of different video conferencing systems, so you can see all of them in that one location. We'll try to add another one. We have to log in. As I said, we can use edugain, so I will be redirected to PSNC page. I will enter my credentials, hopefully correctly. No. No. Okay, so we will make a test and add the room. We can use both signaling protocols, so H323 and SIP. We'll show just H323 now. So the only thing at the beginning is to press the start button, and the system will ask user to call provided number. So we will now call that number using 57580940. Yeah, there are two files. There are two files. Okay, I will start the test. Or maybe we'll be on time. So
you have successfully dialed to the EduConf testing service. You may now disconnect.
Okay, and this is the first step I mentioned. Can we now disconnect, please? And now the system is supposed to make a callback so that the virtual terminal will call this Thunberg device here.
This is the EduConf testing service. The call will be disconnected in a few seconds.
Okay, thank you, Rui. Okay, and based on this two connection system, try to gather as many information as possible. Of course, based on IP address, it is possible to point the country, but it's not possible to find the city and street. So I have to help. Yeah, okay, and now using Google Street View, we can automatically add a location of the photo. Okay, something like that. And that's all. We'll have to also give some information about technical contact to this video conferencing device, and after adding this, we are already on the directory and we are able to find this terminal on the map. Yes, and that's all. So I hope it looks quite simple to test and add video terminal into the directory, but how it works in background. This is the dial request scheme. So user press start button and the directory forwards this request to monitoring system. The monitoring system is responsible for creating a virtual terminal. The call gen is used from Opal library. And this virtual terminal is being registered in the gatekeeper. After that, all required information to perform this test is being sent to the browser using going through the directory and then to user browsers. And user is asked to make a call. Then, based on IP address of user, geo IP location is being performed. I will explain that in a second. So here again, user chooses test and slide start button. The testing engine sends a request to monitoring, and monitoring is responsible for preparing the test infrastructure. And after the test, after it's ready, user is asked to call a virtual terminal, and then monitoring makes analysis of whole connection, so the result and status of the call, user terminal data as IP address, as GDS number in this case, as ID alias or SIP URI. Geo-positioning is being done, and we have to check whether the address which was taken from this connection is actually terminal or gatekeeper address, because as you can see, there is an issue. IP address of the terminal may be covered by IP address of gatekeeper, which is normal, but we have to check whether we are storing gatekeeper information or terminal information. Of course, from our point of view, it's better to have terminal information, but it is not clear, so we created an engine for checking whether IP address is for terminal or the gatekeeper. How does it work? Again, directory and testing engine is making the test check request. Monitoring is creating again the virtual terminal, as you can see. And this virtual terminal there is a gatekeeper request message sent from virtual terminal directly into gatekeeper or terminal, because we still don't know whether this is what kind of device is it. If we receive any feedback from this device, so gatekeeper confirm or gatekeeper reject information, we can assume that this device is actually a gatekeeper. And if there is timeout, then we can assume that it's terminal. And this information is being sent then from directory, from monitoring again to the directory. And this is the second step of the test service. So the directory is making the test request to monitoring. Again, monitoring is creating virtual terminal and registering it to the gatekeeper and send information to user browser via directory that such connection will be expected. And then in the last step, 6, virtual terminal is performing VC call directly to user's terminal. This is the second step, as you saw during the demo. And here again, in few words, testing engine sends request to monitoring. Monitoring is again responsible for preparing the whole test infrastructure and inform user to expect the incoming call. And then the call itself is being performed H323 or SIP, depending on what user wants to test. The last step, in order to get into the directory, for testing purposes, it's not necessary. It is just required to add in terminal to the directory. And this step just can be skipped, but if user wants to add terminal to the directory, user is asked also to update contact information, addressing details, add Google Street View location photo, and of course confirm all collected data. There is also one very important, from our point of view, functionality. It is testing functionality of VC infrastructure. How does it work? The automated test calls are being performed from time to time between virtual terminals. Those virtual terminals are being simply registered to different gatekeepers. So if we will make a call between two terminals registered in different gatekeepers, we can be sure that the whole infrastructure is working. And during one test process, the full measure of all gatekeepers is being performed, so we are able to check the whole infrastructure in one step. This is a schema how does it actually work. So monitoring creates two virtual terminals, both are registered in different gatekeepers, and then test is being performed H323 or SIP, and the results are stored in the database of directory, and if in case of any problems with the infrastructure, the email-based notification is immediately sent to users just to check what is wrong. And now we would like to show you a very short commercial movie about EduConf.
EduConf. Become part of the global NRAN EduConf directory. Creating a video conference network that works. The goal of EduConf is to create an effective video conference network that saves time, money, and improves teamwork. With EduConf, users will be able to easily find and use video conferencing facilities across Europe. Providing video conferencing, testing, shared directory, global gatekeeper, and network monitoring.
EduConf supports the education and research organisations in Europe and around the world. Video conferencing is a vital part of their day-to-day business.
EduConf operates one of the global gatekeeper and plays a major role in the global dialing scheme of 164 numbers.
We are monitoring the gatekeeper network because they are fundamental to make the video conferencing terminals work.
The testing service adds confidence in the use of the video conferencing. My users can be assured that we have done quick tests and everything will work fine.
EduConf directory lets me search for and find the video rooms. All of them have been tested and as a contact to call.
EduConf is creating a global video conference network at the European level, providing new tools to promote collaboration among researchers and educators. Become part of the global NREN EduConf directory. Join our network and register now your video conference terminal at educonf.gn.net.
Thank you very much. Please register your video terminals if you wish. educonf.net. If you have any questions, do we have any time?
Yeah, thank you very much for your presentation. Any quick question from the audience? No, everything was clear. Everybody wants to join to the EduConf directory service.
You're welcome.
A couple of announcements before you leave the room. The demonstration and the posters will be available tomorrow as well. Please fill out the evaluation form, clicking the feedback button of the TNC 2015 conference website. The gala dinner. Tonight, the gala dinner buses will leave the pier side of this building at 7:15. So be sharp. The bus is back. Was announced during this day via email. And the last announcement for tomorrow, the conference started slightly later with the coffee, so you have 30 minutes to wake up after the good gala dinner. Enjoy the gala dinner and have fun. Thank you.